A'udhu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. Dear student, Assalamu alaikum. Apex Grammar School. So today's our lecture is class 9th, subject physics, chapter number 6, work and energy, as we are doing last time. Topic of today's lectures are 6.3 and 6.4. We will cover these two topics. We will try to cover these two topics, 6.3 and 6.4. Pages covered today's lecture will be 121, 122, 123, and 124. If you open 9th class textbook, you will find these pages. First of all, we will start from the page number 100 and 121. Our page will be 121 and we are doing 6.3 and 6.4 topics we will cover today. I repeat, class 9, subject physics, chapter number 6 we are doing now. 6, work and energy. The name of the chapter is work and energy. Topic of today's lecture are 6.3 and 6.4. 6.3 is kinetic energy and 6.4 is potential energy. And pages of today's lecture are 121. You will find this topic kinetic energy 6.3 on 121 page. If you open 9th class textbook, 121 page, you will find this. Please open 121 page. You will find the topic kinetic energy. This is a chapter we are doing, work and energy, unit number 6, work and energy. So our topics, as we have discussed 6.1 and 6.2 in our last lecture, we discussed about energy. I give you a quick review about energy. A body possesses energy if it is capable to do work. This is the definition of the energy. So energy has, now today's lecture we will discuss mechanical energy possessed by a body is of two types. Mechanical energy has two types. One is kinetic energy and potential energy. We will discuss soon now. Mechanical energy, we will discuss today's lecture. Mechanical energy, and mechanical energy has two types. One is called kinetic energy and other one is called potential energy. So in 6.3 we will discuss kinetic energy, and in 6.4 topic we will discuss potential energy. Okay, so I start my lecture 6.3, which is on page number 121. 121 page. Please open 121 page. And this topic 6.3, which is kinetic energy. First of all, I give you the definition of the kinetic energy. What is kinetic energy? The energy possessed. This is the big definition. You need to memorize this by heart because this comes in board examination. They ask you what is defined kinetic energy. Then you will write this definition. The energy possessed by a body due to its motion is called its kinetic energy. And again, the energy possessed by a body due to its motion is called its kinetic energy. Now I discuss the example now. Which things have possessed kinetic energy? Moving air. Moving air is called, whenever the air is moving, we say this wind is blowing. This is called wind. The name of moving air is called wind. We can use wind energy for doing various things. This wind energy, when the air is moving, we say this is wind. So we can use this wind to do the wind energy for doing various things. For different purposes, we use this. We use this for different purposes. Uh, this energy. It drives windmills and pushes sailing boats. So this is a sailing boat. So with moving air, which is called wind, it moves our sailing boats. It pushes our sailing boats. So it also drives the windmills. So we can use this wind energy for doing, performing different various things. So first of all, the use of this moving air, we pushes a sailing boats with the help of moving air. Similarly, moving water in a river can carry wooden logs. So if there is a water in the river, so it has energy, it possesses energy. It can move the wooden log, or wooden block, or wooden things toward wherever it is flowing. So it means the river water also possess energy because it can move the wooden log. Wooden log means piece of wood. Now we move towards next. Can also be used to drive turbines for generating electricity. So this can also moving water has the possess energy when it is dropped from a height. So it has energy. It can runs the turbines, so we can generate the electricity with the help of whenever running water possess energy. It has the kinetic energy in it. It possesses the kinetic energy. So with the help of this kinetic energy, when we drop this water on the turbines. So turbine works and then we generate the electricity. So it has energy. That's why we are producing the electricity. Thus, a moving body has kinetic energy because it can do work due to its motion. So as I told you, the motion stops moving as well as soon as all the kinetic energy is used up. So, so I told you the definition of the kinetic energy. The energy possessed by a body due to its motion is called its kinetic. Why I'm saying moving? Because whenever the water is moving, it possesses the kinetic energy. So this kinetic energy is used to generate the electricity for us, for our homes, for electricity produced by the moving water. So these electricity is used in our homes. So let's suppose consider a body of mass m. Let's suppose the mass of the body of mass m moving with velocity. We suppose that the wooden log has a mass. I gave you the definition of the wooden log. Whenever the wooden log is in the river water, so this wooden log will move in the direction of where since the water possesses energy, there is energy in the water, moving water, so it can take our wooden log wherever it is flowing. So suppose let's suppose the mass of the wooden ball is m, and it is moving with the velocity v. So the body stops after moving through distance s due to the some opposing force such as friction force acting on it. So let's suppose there is a force which is acting in opposite direction. As I told you, what is friction? So whenever the body is moving, so there is a force moving on the opposite direction of the force, that is called the friction force. So let's suppose friction acting on it. The body possesses kinetic energy and it is capable to do work against oppositely force F until all the kinetic energy is used up. So you know that whenever we talk about kinetic energy, Ke stands for kinetic energy. Kinetic energy, the energy possessed by a body due to its motion is called kinetic energy because there is a opposite force acting on the body, which is called the friction force. So as long as the friction force acts on it, so all the kinetic energy will be the body will stop when all the kinetic energy will be converted into work done. So work done by due to its motion. So kinetic energy is denoted by Ke, and you know the formula for work done is Fs. Let's suppose initial velocity of the wooden log. Let's suppose velocity will be v, and final velocity when it stops. You know that when the body stops, its final velocity is zero. And we have discussed this formula F is equal to ma. Just separate a is equal to minus f over m. Just separate a. So if you take over this, so f over m, so acceleration is equal to minus f over m. So why this negative sign is because in f is equal to m formula, f is equal to ma formula, we don't see any negative sign. But because this is the opposite force, motion, since motion is opposed, hence the negative sign is negative. That's why the negative sign is. So I will place in second law F is equal to ma. I will place minus sign because of the motion is opposed. Because the motion is opposed by the friction force, that's why acceleration is minus f over m. So I will use the third equation of motion. We know the third equation of motion. The third equation of motion is S is equal to Vf square minus. This is our third equation of motion. 2As is equal to Vf square minus Vi square. So I will put kinetic energy is equal to Fs. So kinetic energy will be Fs. Vi equals to V. Vf is equal to 0. F is equal to ma. A is equal to minus f over m. We will put this A as F and Vi in our this equation. 2As is equal to Vf square minus Vi square. So I will A is what is A? A is minus F over M. I will put minus F over M. S will be remain as it is. So Vf is equal to 0 and Vi is equal to V. So 0 square will be 0 minus V square. So if Fs, if I take M on this side, it will be go on this side. It will be, if it is divide here, over there, it will be multiply. Fs is equal to half mv square. Student, please stop for a while. So I start again. 2as is equal to vf square minus vi square. This is the third equation of motion. So I will substitute a equals to minus f over m, or s will be as it is. Vf is equal to 0 and vi is equal to v. So this m is dividing here. If it is go on the other side, it will be multiplied. So half mv square. So Fs is equal to Ke. So I will substitute Fs is equal to Ke. So my kinetic energy will be half mv square. So I have discussed kinetic energy. Kinetic energy is equal to, formula for kinetic energy is half mv square. So I repeat what we discussed. We discussed about kinetic energy. First of all, we kinetic energy, the definition of the kinetic energy is the energy possessed by a body due to its motion is called its kinetic energy. This is the definition of the kinetic energy. You need to memorize this by heart. Okay. Then we discuss the examples of the kinetic energy. What is kinetic energy? Moving air is called wind. Since it is moving, so it possesses the kinetic energy. We can use this wind energy for doing various things. So what can we do with the help of wind energy? Wind energy, it drives windmills and it, with the help of wind we can push the sailing boats and we can drive the windmills. Okay. Similarly, moving water in a river can carry wooden logs through large distances. So for example, there is a piece of wood in the river. Since the moving water has possessed the kinetic energy, so it can move the wooden log to a large distances. That's why we say moving water has possessed the kinetic energy. So this water can, when this water is thrown. So it's energy. So since it possesses the kinetic after moving through the. So this suppose consider a body of mass m moving with velocity v. So and the distance, the body stops after moving through a distance s due to the some opposing force. What is the opposing force? Friction force is called the opposing force. Whenever the body moves, there is a reaction force called the, which stops the motion of the body, that is called the friction body. Let's suppose the friction. is acting on the body, it will stop the body, then all the kinetic energy will be converted into the work done. So how we can write it mathematically? Kinetic energy, kinetic energy is equal to Fs. So if we Fi is Vi equals to V, since Vi is equal to initial velocity is V and final velocity is 0, and we know F is equal to ma, so second law of motion. So A, if we separate A, so A equals to minus F over m. If we use this equation, say third equation of motion, and third equation of motion is equal to 2AF is equal to VF square minus Vi square. So if we substitute Vf is equal to 0 and Vi equals to V in this equation, and A equals to minus F over m. So if we put A equals to minus F over m and remain as it is. So m is divided here. If it is go on the other side of the equation, that will be multiplied. So 0 square when added with V square, that will be V square. So m is multiply here. If it is go on the other side, it will be plus multiply m. So Fs minus this minus sign will be cancelled with this minus sign. So Fs is equal to half mv square. And you know Fs is equal to Ke. Kinetic energy, if we put Fs is equal to Ke, that will be half mv square. So kinetic energy possessed by a body m moving with velocity v. Kinetic energy formula from now is kinetic energy is equal to half mv square. This is very important formula, guys, because we will use this formula in our numericals as well. So kinetic energy is equal to half mv square. Now we discussed the example 6.2, which is on page number 121. If you open 9th class textbook 121 page, you will find this example 6.2. Now I am just going to discuss example 6.2. A stone of mass 500 grams strikes the ground with a velocity of 20 meters per second. How much is the kinetic energy of the stone at the time it strikes the ground? So I will write the data first. So given data is mass is 500 grams. So we need to convert this into kilogram because the unit of mass is kilogram. So 500 divided by 1000, it will be 0.5 kilogram. Now V is given to me 20 meters per second. If you look at the example, so V velocity is 20 meters per second given to me. What is he asking? He is asking how much is the kinetic energy. So in this way, in this formula, we will use this formula. Kinetic energy is equal to half mv square. So mass is given to us and velocity is given to us. Since two things are given to us, then we can easily find the kinetic energy with the help of this formula. Ke is equal to half mv square. So I'm just putting the values. So this is the formula. Kinetic energy is equal to half mv square. So 1 by 2 m is 0.5 kilogram and velocity is 20 meters per second. If you take 20 square, that will be 400. 0.5 kilogram. If you solve this, 400 multiplied by 0.5 divided by 2, you will get 100 joule. So our result will be kinetic energy is 100 joule and the unit of kinetic energy is joule. Okay. So thus the kinetic energy of the stone is 100 joule as it strikes the ground. So example, I repeat, a stone of mass 500 grams strikes the ground with the velocity of 20 meters per second. How much is the kinetic energy in the stone at the time it strikes the ground? So in this numerical, we need to find out the kinetic energy. What we were given the mass. Mass is 500 grams. We convert this into kilogram because the unit of mass is kilogram. But dividing by 1000, you will get 0.5 kilogram. 500 divided by 1000, you will get 0.5 kilogram. So its mass has been converted into kilogram. Now velocity is also given to me. Velocity is given to me 20 meters per second. So what I will do, I will write the velocity which is 20 meters per second. So I will use the formula since I want to find out the kinetic energy, and the unit of kinetic energy is the formula for kinetic energy is half mv square. So I will just putting the values. Mass is 0.5, velocity is 20. So if you solve this, 20 square is 400. 400 multiplied by 0.5 divided by 2, you will get 100 joule. The kinetic energy of the stone is 100 joule. So this is the student. This is the end of the topic 6.3, which we discussed kinetic energy. Now I am moving towards the topic 6.4, which is called the potential energy. So first of all, I will give you the definition of the potential energy. Then we will discuss the uh, examples of the potential energy. Potential energy possessed by a body due to its position is known as potential energy. Is called as its potential energy. Due to its position, the energy possessed by a body due to its position is called as its potential energy. Suppose if you have a brick in your hand, and if you carry this brick on the roof of your house, so this brick has a potential energy because it has a position from the ground. So if you throw the brick on the floor, it will it can damage the things which are lying on the floor. So it possesses energy. So what kind of energy it possesses? It possesses potential energy because it has a position with respect to the earth. Example, we also consider the example of the hammer. When the hammer is raised with the hand, so raised hammer possesses the potential energy because it can hit the nail. If we hit the nail will be suppressed. The nail will be going to the wood. Okay, so the because it has a position. Raise your hand. Hammer is in your hand. If you raise the hammer in your hand, so raised hammer possess the potential energy. Similarly, hammer raised up hammer raised up is example of the potential energy. Similarly, stretched bow with possess this is the bow, so it possess the potential energy. Stored water possess potential energy because I have already told you if you store the water at some certain height, so it is a potential energy will be stored in it. As long there is a motion in the body, you will say this is the kinetic energy, and when the body at certain height it will stop, so it possesses the potential energy. If you take the brick on the top floor of your house, so if you take it at rest, the potential energy will be stored. But when this brick is thrown away, it will come back to the earth. So this potential energy stored in the brick will be converted into the kinetic energy. According to the law of conservation of energy, energy never created, never destroyed, but it converts from one form to another form. So stored water possesses the potential energy due to its height. A hammer raised up to some height has the ability to work because it possesses potential energy. Stretched bow has potential energy due to its stretched position. Look, this is the stretched position. This has a potential. When released, the stored energy of the bow pushes the arrow out of it. The arrow will move away from the bow. So because the energy has stored in it. The energy present in the stretched bow is called the elastic potential. The energy in the stretched bow is the elastic potential because there is the elasticity in this bow. Okay, in this string. In the string there is the elastic. So this is called elastic potential energy will store in the stretched bow. So suppose let the potential energy released by a hammer is due to its height. The energy present in a body due to its height is called the gravitational potential energy. Let a body of mass m, if we are supposing same thing as we discussed in kinetic energy. Let a body of mass m raised up through a height h. Since suppose this is the hammer, it has the mass m, and if it is raised at some height, let's suppose that if its raised height is h from the ground, the body will acquire potential energy equal to the work done because it has the ability to do work. That's why all the potential energy will be converted to work done. Suppose a potential energy PE is equal to FH because the potential energy can do work. So F into S is the formula for work done. So potential energy is equal to Fx. So S will be replaced with H here. So F multiplied by H. So F is W. W is equal to mg. So F is equal to, you know the formula, F is equal to W and W is equal to mg. Just replace F with W, W multiplied by H, and you know W is equal to mg. So our potential energy formula will be uh, and W potential energy is equal to WH and W is equal to mgh. So from now our potential energy formula will be, so potential energy is noted with PE. P means P potential, E means energy, potential energy. Our formula is mgh. So potential energy formula is mgh. Okay, the potential energy is released by a body at a height h with respect to the ground. It's mg and is to the work done in lifting the height h. So our potential energy formula is P is equal to mgh. So he has given the description for this formula as under. Okay. Now from now this is the definition of the potential energy. The energy possessed by a body due to its position is known as its potential energy. I gave you the example of the potential energy. A raised hammer is an example of potential energy. Similarly, stretched bow possesses the potential energy, but it has a elastic potential energy stored in it. So raised water, when thrown, it has ability to do work. It can run the turbine, so energy stored in the stored water is also the potential energy. So I told you by the law of conservation of energy, energy never destroy, never possess, never created, never destroy, but it converts from one form to another form. Why I'm saying this? Because whenever you throw the brick from the top floor to the ground floor, so all the potential energy is converted into the kinetic energy, and this kinetic energy when hits on the floor, so it will create the sound. So kinetic energy is converted into sound. That's why I'm saying potential energy converted from one form to another form. So from now, our formula for potential energy is FH, and you know F is equal to W, and W is equal to mg. So our formula is potential energy is mgh. So we will use this formula potential energy is equal to mgh in our numericals as well. Now we discuss the example 6.3. A body of mass 50 kilograms is raised to a height of 3 meters. Is raised to the height of 3 meters. What is the potential energy? So you know, I will write the data. Mass m is 50 given 50 kilogram is given to me. Then height h is 3 meters, and you know the value of g acceleration due to gravity is 10 meters per second. I will use the formula Pe is equal to mgh. So I will just put in the value. Mass is 50, G is 10, and H is 3. If you multiply this, you will get the potential energy 1500 joule. Kinetic energy has a unit joule, potential energy has a unit joule. So energy unit is joule. So this is the end of the example 6.3. Now I am discussed example 6.4. This is the last example of this topics today, 6.3 and 6.4 topic we were doing. So example number 4, 6.4. This is the last. A force of 200 Newton acts on a body of mass 20 kilograms. The force accelerates the body from rest until it attains a velocity of 50 meters per second. Through what distance the force acts? I repeat example 6.4, which is on page number 134. A force of 200 Newton acts on a body of mass 20 kilograms. The force accelerates the body from rest until it attains a velocity of 50 meters per second. To what distance the force acts? So I will write the given data. Force is given to me. You know the unit of force is Newton. So force is 200 Newton and mass is given to me 20 kilograms. Velocity is 50 meters per second. We need to find out the distance s. So we use the formula work done on the body will equal to kinetic energy gained. So you know Fs is equal to half mv square. In the last topic, I told you Fs is equal to Ke. So Ke can be replaced with Fs. So since we want to find out the distance, so I will F is multiply here. If it is go down, it will be divided. So this 2 will be, I know I'm just putting the values. Mass is 200 gram, mass is 20 kg, and V is 50. So 50 square, and this 2 will be down, and F is multiply here since we want to find out the distance. So F is multiply here. If it is go down, it will be divided. So force I will put 200 Newton. So if you solve this, you find the distance, which is 125 meters. I repeat, force is given to me 200 Newton, force is given to me 200 Newton, and mass is given to me 20 kilograms. So velocity is 50 meters per second. What I want to find out? I want to find out S, distance S. So you know the work done formula. So all the work done will be converted into kinetic energy. So kinetic energy is equal to half mv square. Since we replaced Fs is equal to Ke, so Ke can be replaced with Fs. So just separate out S because we want to find out S. So F is multiply here, it will go on the other side to divide it. So mass is 20, velocity is given to me 50. So this 2 will be down and F is 200. If you solve this 50 multiplied by 20, 50 square, and then multiply whatever the result will multiply with 20, and then 200 multiply with 2. If you solve with the help of calculator, you will get 125 meter. This is the distance. This is the distance uh, from the x. This is the distance. The force through what distance the force x. The distance 125 force will x. So this is the end of the example 6.4. So today what we discussed the kinetic energy. We discussed the mechanical energy has two types, kinetic energy and the potential energy. We discussed about the kinetic energy, the energy possessed by a body due to its motion is called kinetic energy. This is the definition of the kinetic energy. Then we discussed the formula. Kinetic energy is equal to half mv square. Then we discussed we use this formula kinetic energy equal to half mv square and solved example 6.2. Next, kinetic energy is equal to half mv square, just putting the values. Mass is 0.5 and velocity is 20 meters per second. If you multiply this, you will get 100 joules. Similarly, we discussed about potential energy. The energy possessed by a body due to its position is called potential energy. So we discussed potential energy is equal to F cross H. So F is W is equal to H. So W is equal to mg. So weight of the body is W. So our potential energy formula is mgh. We just put the values. With the help of this formula, we solve the 6.3 example. I use this formula as the PE is equal to mgh. So our PE potential energy is 1500 joules. So with the help of this formula, we solve example 6.4, which is I use the formula half mv square. I separate out s and then putting these values into the formula. I got a distance from the force action. So S is equal to 125. I hope students will understand all these topics 6.3 and 6.4 clearly. If you have any problem regarding this 6.3 and 6.4 topic, you can feel free to ask. So your homework is please memorize topic by heart and write once on the register. You have on the next lecture, we are conducting a test, MCQs test of chapter number 4 and chapter number 5. So once you you need to discuss thoroughly, you need to do the MCQs, chapter number 4 and chapter number 5. For this, you need to raise your hand and answer the question. Please make sure your mic and headset is working on that day properly. Everyone has to participate. It will not be just one person is asking, other will are quiet. Everyone has to participate in the numerical. So thank you. This is your test. Next lecture we will conduct the test. Chapter number 4. I will ask the MCQs and you will have to answer me by turning on your mic. Okay. Thank you. Any question, if you have, please feel free to ask. Students, if you have any question, please let me know. Raise your hand, ask question.
आप कहते हैं कि डेफिनेशन